Hey there, welcome space weather enthusiasts. We're bringing you the weather all the way from the sun down to the surface of the planet in the lower 48. Thanks for tuning in to the Daily Space Weather Show. Today's imagery starts out with, and we do have some imagery from SDO for you as well, not to mention the GOES 16. This is the Proba 2 mission. That is 174 angstroms. And a couple things to note in the past 24. So here's the northern hemisphere. We do have some active regions setting there in the west. But more importantly is what's rising in the east. A quite large sunspot group lies behind that solar limb. So that is something in the forecast. Going to see a large sunspot rise here soon in that northeastern limb. Here's the equatorial view. The most active sunspot has been the one south of the Earth scale there, over on the left, in the southeastern quadrant. A few sunspots still do have the potential to produce large flares, such as that bright group in the southwestern quadrant in your lower right screen. Again, the most active sunspot has been the one just northeast of the Earth scale there. It has produced an M-class flare just earlier this morning. The first M-class flare in a few days, actually. And here's a close-up of that. Dag! And again, we are going to bring you some SDO imagery, but first, don't forget to press the like button. Yeah, press the like button. If you're new to the channel, press the subscribe button. Congratulations on realizing that the most comprehensive daily space weather content in the world exists. We also do meteorology segments. We throw them in at the end of the video as a value-added service. So press the like button. Don't worry, we'll wait. And don't forget to visit the links below the video as well. If you haven't seen our playlists, go check those out. Some videos on there that have nothing to do with space weather or meteorology. So again, check out the playlists, press like, subscribe, share, etc. Leave a comment, even a derogatory one. We find those just as amusing as the complimentary ones. And thanks to our new YouTube viewers as well. Especially thanks to the Smash team. We'll call back to that momentarily. Now, the links below the video in the description are super important. We would prefer to keep these videos existent. So why not help us offset our massive operating losses by visiting our Hemp Lucid shop and picking up some gear from there. The most popular products are the water-soluble CBD tinctures. Maybe try those out if you haven't. Or perhaps try the mushroom gummies. You could also try the Stress Immune Sleep. And what's the other one? The full stacks. Save $15 on the broad spectrum CBN capsules, the immune stacks, the stress stacks, and of course you can get them in the full stack as well. Save even more money there. $70. Also some body balms and so forth from Hemp Lucid. Links below the video to the Hemp Lucid shop. If you are planning to shop at Hemp Lucid, please shop via our link. Get us the credit for your purchases, and let us know in the comments if you have used the products. We're interested in what you think of them. Also, if you haven't picked up any eclipse glasses, you know there's an annular eclipse coming on October 14th to places like Texas, right? So, but beyond that, don't you want to be able to go out and look directly at the sun? So maybe pick up a 5-pack. Those are the high-quality eclipse glasses. Not the paper ones. Those are the like legit plastic ones. And they make great gifts. $33 for a pack of 5 eclipse glasses. Don't try to drive with them or do much of anything besides look directly at the sun, as you won't be able to see jack except the closest star. So at the moment, you'll be able to see sunspots with the naked eye. Remember, folks, the sun is about the size of the full moon. So, yeah. Eclipse glasses. If you don't have the ability to look directly at the sun, shop at our Amazon shop in the Spaceware collection. You'll be able to pick some up at amazon.com/shop/smashomash. Last but not least, save $25 on apparel at the merch shop. Links to the Smasho merch below this video in the description, as well as on the homepage at smashomash.com. And if you want to see peace brought to the galaxy, peace, freedom, and liberty brought to the galaxy, then support the Galactic Federation Special Forces. Perhaps call out their motto, Universum Liberate. If that's a little bit too controversial for you, sorry about that, but unit patches tend to be a little bit provocative. The symbolism represents the galaxy, signal integrity and security, as well as instantaneous galactic scale reach. Again, save 25% on all clothing at the merch shop. Convince your friends and foes that you're a member of the Illuminati by calling out the Galactic Federation Special Forces motto, Universum Liberate. And let's move on here to one more way to support the channel. The best way of all, become a member of the Smash Team, smashomash.com/Smash Team. There's a bronze level. It costs you $0 a month. There's a silver level. It's $2.99 a month. There's a gold level. It's $9.99 a month. There's a gold annual paid-up subscription, which is the best value of all. It's almost like getting 4 months of a gold membership for free. You'll get some extra content, but most of all, you'll be able to support the content that we're trying to keep visible, existent, and public for everybody to view on YouTube. So that's part of the reason why it's exclusive to YouTube. Help support the channel by becoming a member of the Smash Team at smashomash.com/Smash Team. And check it out. There's a massive prominence happening right now as we create the video. It's pretty sweet. Check that out. Huge crown prominence going off right now. That's the past about 2.5 hours from the GOES 16 SUVi. Happening right as we make the video. Part of that filament remained anchored up there, so the crown prominence will continue. Part of that is becoming a coronal mass ejection as we produce the video. We'll show you an update on what's going on with that a little bit later. Oops, there we go. There is the SDO continuum there showing sunspots. And we've seen a little bit of degradation, I think, over the past 24 hours here. Besides this group in the northeastern quadrant. So a little bit of growth there. Besides that, a little bit of a downgrade in sunspots. We do have a complex set of sunspots setting there in the northwest. That's capable of producing large flares. Also, the southwestern group is a magnetically complex sunspot group. It could produce large flares still, even though it has degraded a little bit. Here are the magnetic fields, colorized magnetogram. And again, we'll be keeping an eye on that northeastern limb in the upper left, as there is a large sunspot group about to rise up there. Moving along to volcanoes, we want to see what's erupting on planet Earth. So let's check the list. Stromboli, and there's a lava flow on the Sierra del Fuoco. So a new effusive eruption began there. Lava spattering and cascading down the slopes. Mount Mayon in the Philippines producing an unknown volcanic ash plume. Mount Ibu exploding, flight level 070 over Halmahera, Indonesia. Luitolo, volcanic ash to 7,000 feet over Luitolo. Semeru exploding, flight level 140. It's a 14,000-foot ash plume. Dacono, 7,000-foot ash plume as it explodes. Sangay exploding, 20,000-foot ash plume over Ecuador from it. Revenador exploding, flight level 140. and Sabancaya exploding flight level 240, a 24,000-foot ash plume over Peru from Sabancaya. And let's check earthquakes. So there are the past 90 days. No major quakes over the past 24 hours. A few with a 5 or greater magnitude. Starting out with this 5.0 at Indonesia. That was at 16:15 Universal Time yesterday afternoon. Then about an hour and a half later, a 5.4 off the coast of Sumatra in the Indian Ocean. That was at 17:47 Universal Time. And then a lull of 5 and greater magnitude earthquakes, ended by a 5.0 at Tonga. That was at 1:43 Universal Time this morning. And that's it, I think. Very calm as far as earthquakes over the past 24 hours. Next, let's go back to let's take a look at SDO here now. Once again, we'll look at the AIA instrument. Here we've got three different species of ionized iron there. That's 335, 193, and 94 angstroms together. And the most recent M-class flare did come from this group down here in the southeast. You can see some activity kicking up behind the northeastern limb there. That is what I talked about earlier. A significant sunspot rising up there. Next, let's talk stats. The 10.7 centimeter radio flux has dipped. Now at 156 solar flux units. That's the 1 year chart of the radio flux. The black line there depicts 1 year of the F107, the 10.7 centimeter radio flux. 2,800 megahertz is another way to express that radio signal from the upper chromosphere and lower corona. Space Weather Enthusiast dashboard not forecasting any geomagnetic storms or geomagnetic unrest in the coming days, and I would tend to agree. The last CME really fizzled. It did hit. I believe it was a co-interactive region reacting with the coronal hole wind stream, which we will get to here in a moment. First, Earth's magnetic moment from space. Here are the past 4 hours of Earth's magnetic moment from space, and it is geomagnetically calm. The solar wind has become quite diffuse. The fields aren't super strong. Solar wind speed is not particularly high. So that's the last 4 hours of magnetohydrodynamic pressure out to about 12 Earth diameters. Tiny uptick there at the end of the last 4 hours. Earth's magnetic moment from the ground is looking like this. This depicts magnetic flux density at ground level. Magnetic flux density units are nanotesla. So the last 4 hours have not been optimal for viewing the aurora if you are an aurora chaser. Like I said, it is geomagnetically calm conditions. Check it out. KP 0.67. The lowest average of global geomagnetism we've had in the last 3 days by far. And let's look at the real-time solar wind. So here's the CME that we forecasted, and talk about a dud. That right there is the CME impact, believe it or not. Why is that? Because it's interacting with the coronal hole high-speed stream. So here you can see the solar wind density kicked up, and then when the density came down, the solar wind velocity came up. That's a coronal hole high-speed stream, and it got canceled out by this CME. So that's a co-interacting region right there, and that's a great example of how a coronal mass ejection can mess with, oh, you know what? That's an instrument switch. I stand corrected. That is a switch from the Discover to the ACE. So we do see some additional signals in here. So you see here that's the Discover is measuring 447 kilometers per second, but also 504 kilometers per second, a variation of about 50 kilometers per second. And let's actually switch this to show just the Discover to get rid of that instrument switch. So yeah, this does look like a signal built in here. See, there's two separate signals happening there. You can see the difference in the plasma temperature, which is the green line at the bottom. So it looks like two separate regimes there. A weak, barely noticeable coronal mass ejection strike mixed into that coronal hole high-speed stream. So here's the coronal hole high-speed stream signal. It's like 4.5 to 5.5 protons per cubic centimeter with a speed of about 500 kilometers a second. And then you've got this slower CME interacting with it. And some field variations there happening as well. Anyway, current conditions are, let's switch back to the active spacecraft. At least to show you what's reflected in the space weather modeling framework. Current conditions are very diffuse solar wind there. So likely an error, but it's showing 0.2 protons per cubic centimeter. That's why the Geospace magnetosphere movie looked so weak on the magnetosphere. That's the active spacecraft, so it is the space weather modeling framework is depicting a solar wind density of 0.2 protons per cubic centimeter at 365 kilometers per second, a BT of 5 nanotesla with a BZ of 0. So that's the current situation for the active spacecraft. GOES magnetometers here, they'll be smoothing out in the coming days. Again, because no new space weather is on the way. So following a couple of fairly minor geomagnetic storms, you can expect the GOES magnetometers to look more like this in the coming couple of days here. And let's move to the top view ecliptic plane field plot. So now we may see the South Pole current sheet accelerating, and indeed we do. So there's another great example of being able to use the top view ecliptic plane field plot to forecast sunspots. Yeah, sunspots, because look at the sector boundary crossing has suddenly moved forward. So Earth will be in a South Pole current sheet in probably about 48 hours, maybe a little bit more than 48 hours. Something like Saturday midday, perhaps. Earth will move into this South Pole current sheet. Depicted here in red, there it is, a South Pole current sheet. Earth is currently kind of right in the middle of a North Pole current sheet, and let's look at the line of sight field plot next. You'll see the B field all fanned out there at the end of that. That is typically what you're going to see when the Earth is in the middle of a current sheet. The B field is kind of like the net of the polar fields. It's the field that goes through the magnet, this magnet being the sun. North and south polar fields in green and red respectively, and then the gong magnetogram for the photosphere is in grayscale. And let's take a look at coronal holes. Coronal holes, they show us the progression of the solar cycle in a way that's beyond sunspots. Because what happens is, folks, at solar minimum, the coronal holes are fixated at the poles. And throughout the cycle, they migrate across the equator and settle at the opposite poles, which is what we're watching. Bringing you some unprecedented detail of Solar Cycle 25. We do have some mainly North Pole-oriented coronal holes here on the Earth-facing portion of the solar disk. So let's take a look at those in SDO, 211 angstroms. We can expect an uptick in the solar wind in about 4 to 5 days from this coronal hole right here. So it is pretty much right on the equator there. And that will provide some slight increases there for a limited period of time for the solar wind parameters at Earth. So So that's what's going on for coronal holes, and let's move to sunspots. Sunspot number has dipped again, which is, by the way, not panic-worthy. Currently at about 134. 134 is the sunspot number there, reported by the Royal Observatory of Belgium. And again, we still do have some significant flare players here, which we will show you next. So we do have some magnetically complex sunspot groups here. The most active sunspot has been 3450. The small pores ahead of it have evaporated, so that won't get named a sunspot. 3449 is magnetically complex. Also 3447. So we still do have some significant flare players here. Let's take a look at the SDO magnetogram next. There you go. Mostly stable over the past 24 hours, but a little bit of growth in the northeast and a little bit of degradation in the southwest. There is the other HMI instrument there, the SDO continuum. And let's talk energetic particles and solar flares. As far as SEPs go, we ain't got none, but there is a possibility to have some. At the moment, no such luck. No spikes in the ghost proton flux there. It is at baseline levels. Again, the largest flare of the past 24 hours occurred just a few hours before we produced this video. It was a small M-class event, about an M1.1 class solar flare. Let's take a look at that from the perspective of SDO. There's 94 angstroms, one of the two best flare wavelengths. And there is that M-class event down there in the southeastern limb. We've also got 131 angstroms. That is another species of ionized iron, by the way. If you're new to the channel, once again, congratulations on realizing it exists. And let's take a look at what's going on overhead. So here's the star chart for Lehigh Valley, Pennsylvania. The sun chasing Jupiter, Venus, and Mercury. And if you're viewing the dusk sky, you might get a great view of Mars. Just on the other side of the ecliptic there from Spica. So that's your star chart for 40 degrees north latitude by 75 degrees west longitude. Next, a forecast for the solar system. This is where things are today. By the way, that purple glow, that means those planets are in retrograde. They are moving in the reverse motion to the background stars from the perspective of Earth as it moves much faster than the outer planets, putting them in retrograde motion here for the moment. Anyway, here's your 1 week forecast for the solar system. Here's where things will be on October 5th. We will have a gibbous waning moon. Next, our astronomy photo of the day. And this is another sweet one. We're going to be looking at M8, the 8th entry in the Messier catalog. So this is a really awesome nebula in the constellation Sagittarius. And the main feature in this nebulous object is that hourglass-shaped feature in the middle. That is a hot, extremely bright star. illuminating that cloud of gas. And so what you're looking at there is, well, the reddish portion, that is ionized hydrogen gas. And that is a turbulent environment indeed in that nebulous cloud. apod.nasa.gov. Let's take another run at that. That is a good one. It's known as the Deep Lagoon. The Lagoon Nebula, that is. Otherwise known as M8, the 8th entry in the Messier catalog. And let's move on to coronal mass ejections. They've been pretty minor. There was one around midday yesterday, which was interesting. It kind of came out of the northeastern limb. We'll be taking a closer look at that here in a minute. That's 64 frames from yesterday. Here are an additional 46 frames from today, September 28th. Some minor CME events there, and of course, one occurring as we produce the video. We're going to see another one coming out of the northern polar region. It's unlikely to be earthly directed. Let's move on to our Soho-Lasco C2 and C3. Let's break those down. All right, so we're going to bring the C2 back to yesterday. Right around noontime, you see that event there, mostly out of the north. We don't see a halo, but it could be earthly directed. Besides that, these other events not likely to be earthly directed. So there's that event. Here's 927 on the C3. Not a super major CME there. Just emerging from behind the disk around 11 o'clock Universal Time. We'll also briefly show Stereo A. That's where Stereo A is located, by the way. Stereo A is just ahead of the Earth now, orbitally speaking. It orbits a little bit faster than the Earth does. That's why it's where that red dot is located. This image also shows Solar Orbiter, Parker Solar Probe, Bepi Colombo. Stereo B is the blue dot. So here's Stereo A, difference imagery on the right, raw coronagraph on the left. And you can indeed see that CME there on the difference imagery. Let's take a look at our custom views. Here we've got Proba 2 in the middle, Soho-Lasco C3 in blue, Soho-Lasco C2 in red. And let's zoom in one step here to see if we can determine the origin of that CME from the northeastern region. I suspect it came from behind the limb. Let's go in one step closer here. Pretty sure that's from behind the limb, folks. Not likely to be earthly directed, even if it was from the Earth side of the solar disk, as we don't see a halo. So that's the verdict. No new CMEs headed in Earth's direction. Let's move on to filaments. And we still do have a massive number of filaments on the Earth-facing portion of the solar disk. Check that out. You see all those dark features there? Those are filaments, and that is a crazy number, and many of those are quite huge. And many of these filaments, like this one right here, if they eject, they're very likely to have an earthly directed component, if not be directly oriented toward Earth. So those are plasma suspended by powerful magnetic fields there, defying gravity in the sun's atmosphere. Looking at the grayscale image, we're going to count these once again. Let's bring up the last image. DAG. That is a lot of filaments. So first of all, we've got this crown prominence. That's one. We've got a prominence here on the northeastern limb. That's 2. 3, 4, 5, 6, 7. Here's 8, 9, 10, 11, 12, 13. At least 13. There's also a prominence down here, so we'll say 14 filaments. And some of those filaments are gigantic. So, and there are certainly a couple on there that could get a name. I mean, the first one I would name would be this one right here, because if it ejects, it's likely to be earthly directed. So, and if you want to name filaments, do it over on Twitter. Thanks to our new Twitter followers. Congratulations on realizing the Twitter account exists, with the pathetic censorship on all social media. If you've unplugged entirely, we totally understand why. x.com/smashomash is where you can find it. You can also find links on the homepage at smashomash.com. So visit the homepage to find us all over the internet. And yeah, you might even find interesting imagery like this. If you think the planet's overpopulated, please view that map on the Twitter page. So here's what's going on with this CME. Pretty sweet, right? And we've paused for station identification. You've reached the Smash News Network, least busted name in news. So there are the past about 2.5 hours. Massive crown prominence going off. That's ionized helium from the GO-16 SUVI. And as you can see, a large portion of that crown prominence remained intact. Part of it might even be anchoring itself there on a different location there, opposite, on the western portion of the solar polar region. And this brings us to bonus features. First of all, satellite charging hazards. There are none. It is smooth sailing for satellites there. No high-energy electrons building up inside of spacecraft or low-energy electrons building up on the outside of spacecraft. Goes electron flux here kind of at high levels, maybe a little higher than you might have expected. Again, the CME impact was very weak, barely even detectable as a signal, more like a co-interactive region than a real CME impact, but there's the GOES electron flux. Pushing warning levels there, not super high, kind of in a moderate range. There's the 1-year graph to show the context of that. Just right in the middle of the range there for the relativistic electrons. Forecast model here from NOAA, forecasting fairly flat levels. I would tend to agree there. The green boxes of the forecast, the yellow diamonds, the observation. Next, the ionosphere. This is where the electron flux is measured using radiography from the geosynchronous orbits of the GOES-16 and GOES-18. This slice of the atmosphere is at about 300 kilometers. So that's the F layer of the ionosphere, depicted in vibrational frequency, megahertz, millions of vibrations per second. That gas is very diffuse, and it is vibrating. And of course, the noon portion, the area of the planet under the sun at noontime, is doing the most vibrating, as you would come to expect. That area is getting ionized by incoming solar radiation. Here's the anomalygram depicting anomaly in megahertz from a 30-day median. As we zoom in closer and closer from space weather to Earth weather. Keep in mind the ionosphere is still space. 300 kilometers of altitude is the bridge between Earth and space. And here's the latest image. That's 12 o'clock universal time. There's 12 noon universal time for the anomalygram. Quite normal looking ionosphere at the moment. Next, we're going to show total electron content. But first, take a moment to press the like button if you haven't done that yet. If you haven't left us a lovely comment, please do so. If you haven't pressed share, why not share on your social media? Probably like 2 people will actually see it. Congratulations, you've been shadow banned on the internet. It's hilarious that people thought shadow bans were not a real thing. Here comes total electron content, which is free electrons to about 12,500 miles of altitude. That's where your GPS satellite's located. Here are the likely spots to see GPS errors. This is literally a count of free electrons from the inner portion of the outer Van Allen belt down to ground level. And we're seeing fairly well-organized total electron contents here, as is usually the case when we see regular levels of electron flux. We also like to show the anomaly from the 10-day average over North America. And now is actually a good time to see Earth-based signals, perhaps. Only some minor electron content anomalies there. Certainly nothing to write home about. We'll close out space weather with the latest intensitygram and latest magnetogram. Again, there is a sunspot rising behind that northeastern limb. You can mark my words on that. The most active sunspot has been this group down here. It is beta gamma delta class. We also have a significant likelihood of large solar flares up there in the northwest, and from these groups in the southwest. Besides that, no major changes with sunspots. And let's move to meteorology. It's a value-added service that we throw in because I realized like 20 years ago it's too easy to forecast the weather. You've got more instrumentation than you could possibly need if you understand the physics. So here you go. Here's some Earth weather for you. Starting out by looking at Saharan dust and surface level winds. Saharan dust is beating up these 2 low pressure systems. And you can see significant dust here to the north and to the east of those 2 subtropical lows down there, not helping them out with convection at all. Dust from the Sahara. It's the reason the Caribbean is so lush. It's been fertilizing them for quite a while. An immeasurably long period of time. Anyway, let's look at the surface winds and jet streams. Here they are for the east. Shout out to our viewers from this side of the planet. There are the jet streams from the east, the 250 hectopascal winds. Here are the jet streams of Europe, Africa, and the Middle East. Don't forget the surface winds. It is windy in the North Atlantic. It's not a good day for Viking raids. Next, surface winds for the west. Shout out to our viewers from all sides of the planet. If you're viewing from a different plane of existence, universe, timeline, galaxy, etc., please leave us a comment. Last but not least, the jet streams. And there's actually an anticyclone here right around these these subtropical lows, they are getting beaten up by wind shear as well as Saharan dust. They're not likely to turn into hurricanes. They're likely to fizzle out. That is an upper-level high-pressure system beating up the upper cloud tops of those subtropical lows. We've got a massive amount of sulfur dioxide. Check out the sulfur dioxide content, folks. Major sulfur dioxide here coming out of the Alaskan Peninsula there. That's windy.com's map, by the way. Lots of sulfur dioxide around the western portion of the North American continent, period, actually. Check it out. There's Popocatépetl there producing quite a bit of sulfur dioxide, as it is known to do. And there's the full globe map. North America is the capital of sulfur dioxide right now. Check it out. Quite a bit of sulfur dioxide, SO2. Moving right along, here is the clouds and fog over the Americas. That is shortwave radiation from the NASA GOES Interactive Weather Satellite Suite. Here's your weather.gov map. We'll scroll down and show you the key. Looks like some coastal flooding here expected for the eastern U.S. Anyway, if your location is lit, head to the National Weather Service homepage, weather.gov. And here come some forecasts. First, the pressure and precipitation forecast for the lower 48. That is the GFS 72-hour pressure and precipitation forecast. Here is the total accumulated precipitation forecast, since we did see some flooding watches there. Looks like New Jersey is going to get hit. '72-hour GFS total accumulated precipitation forecast in inches is what you're looking at there. Here is the what's really in control of your weather there is the jet stream. It's what makes your weather move from west to east for the most part. And look at that. Really cold air is going to be driven down into the Pacific Northwest all the way into Southern California. Even San Diego is going to see some cold temperatures in the coming days as a result of that jet stream. Look at that huge kink in the jet stream there moving across into the Rockies. That's going to drive cold air right across the U.S. That's your 72-hour GFS jet stream forecast. If you want to make your own forecasts like this one, head to tropicaltidbits.com. We show it daily on the channel because it is so good. Shout out to Dr. Levi Cohen. Next, our lightning mapper. This is what's going on in the past about 10 hours. Kentucky is the lightning capital of the U.S. here. And let's see if we have any terrestrial strikes by checking the real-time lightning map at lightningmaps.org. Highly recommend it the next time you hear thunder, by the way. It could save your bacon. And indeed, we do have some minor lightning strikes here north of Nashville. Pronounce it correctly, folks. It's Nashville. You got to pronounce the town like the locals, not Nashville. What are you, a hick? It's Nashville. Anyway, yes, you can forecast thunderclaps with lightningmaps.org. Once again, press the like button, because we can't continue the video until you press the like button. I know it's hard. I know it's a lot of effort to click on a thing. I know it's very difficult, folks, but I unfortunately, until we detect that you've pressed like, we're unable to continue with the video. So please press like. Yes, I mean you. Get off your you-know-what and press the like button. What is wrong with you? If that makes you mad, make sure you leave a comment. Don't forget to visit our homepage, smashomash.com. Hit us up on social media, press the share button, etc. We've got a Facebook group. There's an Instagram page, Twitter. We're even on Threads for some reason. We've got a permanent invite link to the Discord channel right there. You can also find a link to save 25% on the Redbubble merch. There's the Amazon shop where you can pick up your Eclipse glasses. There's the Hemp Lucid link. Spotify to see original music from our record label, Golden Cat Productions. We're even still on Patreon. You can even donate directly via PayPal, and please do. SmashOmash.com, we created a massive web ring in 2019 to benefit people like you because we realized that we needed our own web servers. Anyway, we're going to close this thing out with U.S. Doppler radar. There's the full 50-state view. Here's the lower 48 view. Here's clouds and fog, shortwave radiation. Last but not least, here's water vapor. And here's your recap. As we bring you the weather, all the way from the closest star, all the way down to where you likely are. And by the way, quick note, if you think this is a chemtrail, you know, an 800-mile long chemtrail, think again. That is where there is a pressure gradient going on, where you've got dry air meeting up with relatively moist air, and at that pressure gradient, clouds form. Yeah. You don't believe me? There you go. There is the pressure gradient that is caused by clouds forming. That part of the sky reached a dew point, and that caused clouds to form. Not caused by chemtrails, not caused by contrails, not geoengineering, not cloud seeding, not HARP, not anything like that. It's just nature. Anyway, that's where we'll close things out. And thanks for tuning into the Smash News Network, Least Busted Name of News. I've got to head back to the bunker because I've been very spooked by listening to a lot of nonsense on YouTube. So since I'm spooked, I'm headed back to the bunker. In the meantime, may that solar wind be at your back. I'm going back to the bunker again. Whoa.